Hey there, friends. We're back with American Miscellany. We are now on essay number 101, really moving through it. We're having a bit of a storm right now. I don't know if you can really see that out in the background. See all that gorgeous movement of the trees? Oh, it's fierce. But let's enjoy it. Let's have a little read here. So this book, American Miscellany, was published in 1865. It's a collection of essays. We've just finished essay number 100, telling us how to live, exactly how to live. If you're interested, now you know, essay 100. But we are now on essay number 101 on page 249. It's about zoophytes, or plant animals. Very interesting. This book is supposed to contain essays that are historical and scientific. So let's learn a little something together. Essay number 101, Zoophytes or Plant Animals. These wonderful productions are so denominated on account of their existence in the shape of plants. They are very numerous, and the greater part of them have so much a resemblance to vegetables that they generally have been considered as such, although the horny and stony appearance of several of the tribe declares them at first view to be of a widely different nature from the generality of plants. In others, however, the softness of their substance and the ramified mode of their growth would lead anyone not acquainted with their real nature to suppose them vegetables. The hard, horny, or stony zoophytes are in general known by the name of corals, and of these several distinctions are formed, either from the structure and appearance of the coral or hard part, or from the affinity which the softer or animal part bears to some other genus among soft-bodied animals or mollusks. The zoophytes may be therefore said to unite the animal and vegetable kingdoms so as to fill up the intermediate space. Belonging to the class of zoophyte worms, the freshwater polyps are infinitely curious. These animals may be found in small streams and in stagnant waters adhering to the stems of aquatic plants or to the undersurface of the leaves and other objects. If a polyp be cut in two parts, the superior part will produce a new tail and the inferior part a new head and arms, and this in warm weather is the course of a very few days. If cut into three pieces, the middle portion will produce both head and tail, and in short, polyps may be cut in all directions and will still reproduce the deficient organs. The natural mode of propagation in this animal is by shoots or offsets in the manner of a plant. One or more branches or shoots proceed from the parent stems, dropping off when complete, and it often happens that these young branches produce others before they themselves drop off from the parent, so that a polyp may be found with several of its descendants still adhering to its stem, thus constituting a real genealogical tree. The polyp likewise, during the autumnal season, deposits eggs, which involve themselves afterwards into distinct animals, and thus possessing two modes of multiplication. It seems paradoxical that a polyp should be able to swallow a worm 3 or 4 times as large as itself, which is frequently observed to happen, but it must be considered that the body of the animal is extremely extensile and that it possesses in an extraordinary degree the power of stretching itself according to the size of the substance it has to swallow. It seizes its prey with a great eagerness, but swallows it slowly, in the same manner as a snake swallows any small quadruped. The arms of a polyp, when microscopically examined, are found to be furnished with a vast number of small organs, apparently acting like so many suckers, by the means of which the animal can hold a worm. even though but slightly in contact with one of its arms, but when on the point of swallowing its prey, it then makes use of all its arms at once in order to absorb it the more readily. Corals, on being gathered perfectly fresh and planted in seawater, appear to put forth small flowers from all the minute cavities or hollow points on the surface. These supposed flowers, for such an idea has been entertained, are real animals, and consequently corals are to be considered as aggregates of animals, either forming or at least inhabiting the calcareous substance of the coral in which they appear. The smaller corals, commonly known by the name of corallines or sea moses, are so many ramified sea polyps covered with a kind of strong horny case to defend them from the injuries to which they would be liable in the boisterous element destined for their abode. The harder or stony corals are equally of an animal nature, and the entire coral continuing to grow as an animal and to form by secretion the stronger or horny exterior, which may be at once considered its home and the habitation in which it has constantly to dwell. A coral of this kind is therefore a large compound zoophyte springing up from the rock, in which it seems to have taken root, and shooting out into branches like a vegetable production. Sponges afford another curious instance of zoophytic life. There are 49 species of this zoophyte, each of which is characterized in the Linnaean system as a fixed animal of flexible torpid of various forms, composed of either reticulate fibers or masses of small spines interwoven together and clothed with a gelatinous flesh full of small mouths on its surface by which it absorbs and rejects water. The existence of the animal inhabitant within its cell has been satisfactorily ascertained by the observations and experiments of Ellis on the Spongia tomentosa. He remarked its contraction when exposed to pain or injury, as well as the expiration and inspiration of water through its tubes. He thus established the position that sponge is an animal, and that the ends or openings of the branched tubes are the mouths by which it receives its nourishment and discharges its excrementitious matter. This position chemistry has since abundantly supported by providing the ammoniacal property of the cellular substance of sponge. Let's try that again. This position chemistry has since abundantly supported by proving the ammoniacal property of the cellular substance of sponge.